Swayam Prabha. Digital India. Educated India.
Hello everyone, this is MS Balakrishna from IIT Bombay once again. It is my pleasure to come back to you with yet another lecture series in chemistry under NPTEL, that is National Program on Technology Enhanced Learning. My first lecture series that was made some time back was on the chemistry of main group elements. This course is about the transition elements. The course title is Advanced Transition Chemistry. Before I begin talking about the chemistry of transition elements, I thought it is very appropriate to make you all familiar about the periodic table by giving glimpse of its history and about who are all contributed to arrive at this beautiful format that explains the physical and chemical properties. It was a wonderful thought process. So, let us begin our journey to understand the history of the periodic table. The title of this lecture 1 is it is all about the periodic table, and you can see the periodic table I have shown here. If you just see different objects under each element, that essentially describes the utility of various elements or in combination with other elements or compounds in day to day life. And this is the modern periodic table with fully named all 118 elements. If you go back to old periodic tables after 103, you can see IUPAC approved names like Bayam, Quadrium, something like that. Now we have a complete periodic table with all 118 elements named. What is periodic table? Place for every element and every element in its place. And ancient India, so when I say ancient India, I am talking about 5 to 8,000 years back, believed in 4 element theory, that is earth, fire, water and air. And about 2300 years back, Aristotle also opined the same thing what Indians felt about 8000 years back. And about 8000 years back, gold was known, and about 6000 years back copper and silver were known to mankind. Similarly, lead was known about 5500 years back, and tin about 3750 years back, and the same time iron was also known. In fact, Indians knew how to extract mercury from cinnabar and distill and purify about 3000 years back. And also they knew how to handle, and they had the concept of fume hood. And those days all these elements based on their brightness and color were related to planets. For example, gold was related to sun, and copper was related to Venus, and silver was related to moon, and lead was to Saturn, and tin to Jupiter, iron to Mars, and mercury is to Mercury. And it is a known fact that the elements are the basic units of all types of matter, including both living and non-living things. And as I mentioned, about 3500 years back, Indians brought the concept of 4 elements. They are earth, air, fire and water. And early civilizations, when you go back to 5000 to 8000 years, the elements such as carbon, sulfur, iron, tin, lead, copper, mercury, silver and gold are known to mankind, and about 1600 years ago elements such as arsenic, antimony, bismuth and zinc were also known to humans. In fact, first element that was discovered was phosphorus, that was in 1669 by German pharmacist Henning Brand. I shall tell you little bit more after a couple of minutes. And in 1735 Swedish chemist George Brand discovered cobalt, and phosphorus was the first element to be discovered in 1669. Perhaps no other element was discovered disgusting manner the way phosphorus was discovered by German merchant, pharmacist and as well as an alchemist Henning Brand. He did not had any intention of identifying or discovering new elements. His sole intention was to make elixir and convert all base metals into gold and also live longer through elixir. So, what he did was he collected 1500 gallons of urine, that is about 5678 liters, and he distilled over a period of several days and tolerated all the stink that is emanating from that one, and eventually he ended up making 60 grams of a glowing substance that we call it as white phosphorus, and it was glowing and during dark, that is the reason it was named as phosphorus. And later he sold that recipe to one gentleman called D. Kraft from Dresden for about 200 thalers, and thalers travelled all over the Europe including England, where he met with Robert Boyle. So, the secret that was made from urine leaked out fast, and John Nuckel in Sweden and later Boyle in London also managed to make phosphorus using the same strategy as that of Henning Brand. And of course, later Ambrose Godfrey Hawkins, the assistant of Boyle, joined together and they started a business of manufacturing phosphorus. And Boyle states that, I quote, Kraft gave no information other than that phosphorus was derived by something belongs to human body. This gave Boyle enough clue so that he too managed to make phosphorus and published the method of its manufacture. Later he improved Brand's process by using sand in the reaction, and of course until calcium phosphate was used to manufacture white phosphorus, this Brand's process was used to make quintal quantities. You can see in the picture here how nicely white phosphorus is glowing, and this is Robert Boyle. Let us talk about Antony Lavoisier, who lived from 1770 to 1789. He wrote the first list containing 33 elements. That means the attempts began with Antony Lavoisier, then known 30 elements he started listing in some order, and also he distinguished between metals and non-metals. The discovery of the role oxygen plays in combustion was an important contribution from Lavoisier. He recognized and named oxygen in 1778 and hydrogen in 1783 and opposed phlogiston theory. So, phlogiston theory says that a material undergoes combustion because of inherent substance that assists or that facilitates combustion, but he told that it is not actually some constituent that is responsible for combustion, it is oxygen and nothing else. So, Lavoisier helped to construct the metric system, wrote the first extensive list of elements and helped to reform chemical nomenclature. Also he discovered silicon in 1787 and showed sulfur as an element not compound in 1771. He is a French scientist cum chemist. After the French Revolution, he was central to the 18th century chemical revolution. He had a large influence on both the history of chemistry and biology. He is widely considered to be the father of modern chemistry. Lavoisier's great accomplishment in chemistry is changing the science from a qualitative to a quantitative one. He discovered and argued that although matter may change its form or shape, its mass always remains the same. That means he was trying to establish the law of conservation of mass at that time. So, Lavoisier was a powerful member of a number of aristocratic councils in France and an administrator of Famille Generale, one of the ancient regime which did not do business in a very fair manner. His political and economic activities enabled him to fund his scientific research. That means while doing business he used some unfair means to make money to support his research. At the height of the French Revolution, he was charged with tax fraud and selling adulterated tobacco, and unfortunately he was guillotined in 1794. Let us talk about Johannes Jacob Bergelius. He is a Sweden chemist. He developed a table of atomic weights and introduced letters to symbolize elements. He discovered besides known elements zirconium, titanium, selenium, silicon, thorium and cerium. And let us look into the basis for classification of elements, and also let us look into the chronological order in which how many elements were known. In 1800 only 13 elements were known. In another 65 years almost it doubled to 63, and in next 120 years it doubled again to have this 107. In 1997 112 elements were known. In 2004 that number rose to 114. In 2016 the modern periodic table is completed with 118 elements. Out of 118 elements we see in the modern periodic table, 94, that means 90 plus 4 including neptunium, plutonium, actinium and proactinium are also found along with uranium in pitchblende are stable elements, and the rest are radioactive. So, that means we have 94 natural elements and remaining are man made. So, let us look into the classification of elements and periodic properties before the modern periodic table came into the picture. In 1800 a German chemist called John Dobreiner, what he did was he arranged several group of 3 elements in this fashion. For example, you can see lithium, sodium, potassium and calcium, strontium, barium, chlorine, bromine and iodine, and he called them as a triad of elements. French geologist A.E.B. de Concourtois in 1862 arranged known elements in the order of increasing atomic weight and made a cylindrical table of elements to display their known properties. I have shown here Concourtois model here. This is the first attempt to systematically arrange all elements known in the periodic table. John Newland, other English chemist, he tried to arrange the 60 elements known that time in the increasing order of atomic weights, and he observed several similarities between the first and 8th element, the second and 9th element and 3rd and 10th and so on and so forth. So, he proposed the law of actives, and you can see here using law of actives he proposed this periodic table in 1864. So, this is how he arranged the known elements. For example, you can see here, so lithium is there, if you count here 7, the 8th one is coming below, and then after again the 8th one is coming below. So, he showed this active law, and this was found to be good up to calcium and was not fully accepted as there were lot of drawbacks and anomalies were there, and he was awarded Davy Medal in 1887 by London Royal Society in recognition of his contribution towards systematic arrangement of elements then known. Interestingly, this observation was similar to music notes, that is every 8th note being similar to the first in octave of music. For example, if you look into Indian classical music, we have Sari, Gama, Pada, Ni, Sa, it repeats, and in the same way Western classical music also we come across Do, Re, Mi, Fa, Sol, La, Ti, Do, like that. So, on the same basis John Newland proposed law of octaves. And in 1860 two chemists, one Dmitry Mendeleev from Russia and Lothar Meyer from Germany, were started working independently to arrange the elements in a order. In 1869 both succeeded in arranging the elements in the increasing order of their atomic weight and showed the similarities appearing in physical and chemical properties at regular intervals. Around 1869 Lothar Meyer compiled a period table of 56 elements based on the periodicity of properties such as molar volume and arranged in increasing order of their atomic weight. This is Julius Lothar Meyer's plot. You can see in some of the old textbooks and also NCERT book shows this plot. And also he showed the relative trends in their atomic mass, and this is called as Lothar Meyer plot. This also you can see in textbooks. So, what Lothar Meyer did was he plotted physical properties such as atomic volume, melting point and boiling point against atomic weight and showed periodically repeating pattern, and in contrast to Newland's octave format, Meyer identified the change in the length of the repeating pattern. In 1868 he was almost ready with the modern periodic table. However, he did not publish his result. However, meantime Dmitry Mendeleev published his periodic table in 1869 with an important statement: the properties of the elements are a periodic function of their atomic weight. That means the physical and chemical properties of elements are a periodic function of their atomic weight. So, this is what he concluded after publishing his periodic table. Mendeleev arranged them known elements in horizontal rows and vertical columns in a table with increasing order of their atomic weight in such a way that the elements with similar properties occupied the same vertical groups. The most interesting and intelligent aspect of his periodic table is he gave importance to the similarities in the empirical formulas and properties, and atomic weight was not strictly followed. Why he did not follow strictly atomic volume, I shall tell you. Despite the lower atomic weight of iodine compared to tellurium, he placed iodine along with halogens and whereas tellurium with chalcogens. He placed iodine in group 7 along with fluorine, chlorine, bromine, and tellurium along with oxygen, sulfur and selenium. That means the thought process was not completely biased towards atomic weight, but he was also looking into the properties and empirical formulas. Also he predicted the properties some of the unknown elements and left gaps at appropriate places in the table. For example, he left gap below aluminum and silicon and called to be discovered elements as Aka, aluminum and Aka, silicon. So, he predicted the existence of gallium and germanium and described their general properties before they were being discovered. So, this is the Mendeleev's work. Of course, you can see in Wikipedia more details about these things. These are the workup towards the periodic table Mendeleev made during that time. So, he was born on 8th February 1834 and he died on 2nd February 1907, living a complete 72 years life, and this is the periodic table that he published in 1871. So, you can see here, as I had mentioned earlier, tellurium has little more atomic weight compared to iodine. However, he placed tellurium along with chalcogens and iodine along with halogens, and you can also see the difference in the atomic weight between cobalt and nickel. Cobalt shows slightly higher atomic weight compared to nickel. So, when Mendeleev proposed his periodic table, the structure of atoms and electrons were unknown. In fact, at the same time Werner also proposed his coordination theory, and in 1893 when electrons were not known, even the concept of atomic theory was not known, and I shall tell you elaborate more about Werner as this course progresses. And of course, you all know that electrons were discovered by J. Thomson in 1897 and modern atomic theory was proposed in 1913 by Niels Bohr, and work of English physicist, we should remember him, Henry Moseley, on X-ray spectra of elements, and the atomic theory showed that the atomic number is a more fundamental property of an element and certainly not its atomic weight. So, Mendeleev's periodic table thus modified as the physical and chemical properties of the elements are periodic functions of their atomic numbers. I repeat again, the physical and chemical properties of the elements are periodic functions of their atomic numbers. So, atomic number of an element is equal to its nuclear charge, that is, in a neutral atom the number of electrons are equal to number of protons in the nucleus. Thus, by simply knowing the electronic configuration, it is possible to recognize the periodic variations and trends across a period or in a group. That means you know how important the periodic table for us to understand the physical and chemical properties and also predict their structural features, reactivity and also application in various aspects. Since periodic law is governed by the electronic configuration, the variation in electronic configuration determine the physical and chemical properties of elements and their compounds, and hence this is very appropriate to say that the physical and chemical properties of the elements are periodic functions of their atomic numbers. Let us try to understand little bit more about Mendeleev's family. So, Mendeleev's mother Maria Dmitrieva Kornilieva was born to a merchant, a family in Siberia, and her husband Ivan Pavlovich Mendeleev was the headmaster of local secondary school. So, Dmitri was 14th child and he had a younger sister. So, when he was 13, Ivan went blind from cataracts and was forced to retire on an inadequate pension. To help the family, Maria became the manager of her family's glass factory, but was completely burned down in 1848, and within a year Ivan died of consumption, that is tuberculosis. At the age of 57, nearly destitute, she left Siberia on foot with her two youngest children Dmitri and his younger sister Elizabeth, walking and hitchhiking about 2150 kilometers to Moscow with sole intention of sending Dmitri to college. And look at the desire and determination of a mother to educate her children. Due to the political unrest and being Siberian, he was barred from entering the college. So, family walked additional 640 kilometers to St. Petersburg. He joined there for science teacher training program with a government scholarship in 1850. So, her dream of Dmitri going to college was fulfilled, but she was not there to see him graduated. So, within few months she died due to tuberculosis and exhaustion. So, Dmitri eulogized his mother in his chemistry book. She instructed by example, corrected with love, and in devoting her son to science left Siberia with him spending her last resources and strength. So, when dying she said, I quote, refrain from illusions, insist on work and not on words, patiently search divine and scientific truth. Dmitri Mendeleev regards as sacred a mother's dying words. So, what Dmitri Dmitri Mendeleev concluded was, it is the function of science to discover the existence of a general reign of order in nature and to find the causes governing this order, and this refers in equal measure to the relations of man, social and political, and to the entire universe as a whole. Let me stop lecture 1 today and continue the remaining aspects of periodic table in my next lecture. Until then, have a wonderful time and see you in my next lecture. Thank you.